Hello folks, thanks for joining us this evening. My name is Richard Barry and I am a Principal Engineer with AWS IoT, specifically on the device side rather than the cloud side. I'm joined today by Tanmoy Sen, who is a Senior Product Manager on the FreeRTOS project. I'm delighted to say we have a couple of guests as well. Amey Inamda from Espressive Systems and Rama Buddhampati from Pentair. I'm going to give a very brief overview of what Amazon FreeRTOS is to kick off with, in case there are people in the audience who aren't familiar with it. And then I'm going to hand over to Tanmoy, who is going to go into a lot more detail about a couple of significant features that we've introduced recently, especially since we last spoke about Amazon FreeRTOS at reInvent last year. So Amazon FreeRTOS is software for devices on the Internet of Things. These are the things that are in the Internet of Things. And very specifically, Amazon FreeRTOS is targeted at very small processors called microcontrollers. These are processing units where you are not going to fit things like Android or Linux or Windows. Typically, we are looking at a few tens to 100K of data memory and perhaps a few 100K to half a meg, that kind of scale of program space, to give you an idea of scale. On the Internet of Things, these are proliferating everywhere in all industry verticals, anywhere where connecting your device can add value to your business or product. And it's worth noting that these small microcontrollers, as we call them, are, they're sold in their billions. If you look at all the cell phones and all the laptops and computers manufactured in a year, well, microcontrollers are many, many times more. On the Internet of Things in particular, you find them in things like sensors, actuators, and I always like to talk about the impact that IoT is having, particularly in industry, because my background's in industrial computing. And there it's considered to be so significant in what can be done by connecting machines, what we call cyber-physical systems, that it's actually being referred to as the fourth industrial revolution. So we're talking about high-impact business value here. Better experience for your customers, more efficient production, more efficient business processes. On the screen at the moment, we see the services that Amazon provide for IoT in the cloud. And you can basically break this down into two categories. Firstly, the services which are designed to enable you to get value after you have connected your device. Here we are looking at things like, well, maybe just the fact that you can remotely monitor your device is where you get your value at one end of the spectrum. To the other end of the spectrum, where we can collect masses of data and use all the compute power we have in the cloud to run very sophisticated algorithms, machine learning, for example. Adding in the device side then, so these are the things that live outside of the cloud, which we collectively refer to as edge devices. Here we have several products. If you have a specific interest in IoT, I would recommend that you go and watch a talk on AWS IoT Greengrass if you're not familiar with that. That enables you to move some of those cloud services and actually run them locally on your premises. Things like machine learning inference, I just mentioned machine learning. So this is Linux class software. Well, it is software which runs on Linux. Unlike the main focus of today, on the microcontrollers, we see the leaf nodes on the network, and this is where the fan-out of nodes is. I'm now going to demonstrate what the value of Amazon FreeRTOS is, talking about a light bulb, okay? A light bulb is a really unimaginative device to talk about on the IoT. I've just talked about how significant it is to be called the fourth industrial revolution. Light bulbs are not going to be part of that industrial revolution, but I choose them because they are very, very simple, and they do just emphasize the point I want to make. On the right-hand side here, we're showing a kind of representation of a program space. Now, historically, if you think of the most sophisticated light bulb application, which maybe flashes in time to music, maybe it changes maybe it changes the brightness with the tempo. I don't know what you do with light bulbs. Historically, you might run a very small 8-bit MCU, and the business value, which is what the functionality of that light bulb is doing, might be a small piece of code written in assembly. Now, if we want to internet connect that, we have the same undifferentiating infrastructure that has to be in place as on the cloud. So the other category of services were all the security, the authentication, encryption, that kind of thing, the ability to manage the life cycle of your IoT device, etc. Very, very analogous on the device side as well. We have the communication stack, the security, the ability to over-the-air update, the requirement to be able to store secrets in order to enable authentication, that kind of thing. So this is what Amazon FreeRTOS is providing on the device side. We also have a product called the Embedded C SDK. Now that also provides the functionality. With Amazon FreeRTOS, though, we go a step further in usability to make it a little bit simpler for our customers. And to do that, we introduce the FreeRTOS kernel to the libraries. If you're not familiar with the FreeRTOS kernel, that's effectively a library which enables you to use multi-threading, even on these very, very small devices. By introducing multi-threading, what we can do is encapsulate a lot of the more complex functionality and remove the burden from our users of having to design that into the kind of sequencing and the data management and the state management of their own software. Instead, we encapsulate that completely in a thread of execution and provide a very, very simple interface. We can highlight here the OTA agent, OTA being the over-the-air update. A bit later, Tanmoy is going to go into that in more detail, and you can see kind of how involved it is. With Amazon FreeRTOS, then you don't need to worry about that complexity. You just have a single API, effectively, that says start the OTA agent at the beginning. That all runs in the background for you. Now, as AWS adds services in the cloud, we are able to have reciprocal clients to access those services in Amazon FreeRTOS. So we're able to enable our users to get very quick access to any new service. It's all about the time to the value, if you like, removing that undifferentiating work for you. And also this is, of course, all provided or backed by AWS, who are a global engineering company, very mature processes. You think of things which are very specific to IoT, like incident response, that kind of thing. Well, it's very mature processes and with global presence. Also, as we design our software, we're very mindful of the fact that we need to ensure that our users have a lot of choice. We don't want, or they don't want to be locked into an ecosystem. They don't even want to be locked into a cloud provider, right? So everything we do, we make sure that we use open standards. So I've mentioned encryption already. TLS is a very well-known open standard. MQTT is the IP-based protocol which we use to connect to the cloud. Again, it's a well-known standard, often used in IoT. We also provide our software with numerous options for your development environment. This has enabled us to work with a lot of different technology partners. And obviously, we are working all the time to add more and give our customers more choice. The MCU vendors we work with have been able to qualify an evaluation platform for use with Amazon FreeRTOS by running all our tests on there, making sure all the tests pass. And then what that enables us to do is ensure that the Amazon FreeRTOS software provides a consistent experience and consistent behavior across all these different platforms. Again, it enables our users to experiment very quickly on numerous different platforms, port their code around, etc. However, when you go to production, of course, you're not going to be using an evaluation board. You're going to have your own production hardware, and only you know what's going to be on that hardware. So we can't provide sort of pre-configured examples with every combination of peripherals, target architecture, and development tools. So to make it easier for our users, again, to port the software to their own production hardware, we have actually open sourced all of our tests as well. Gone a little bit further than that and also provide a document which guides users through the porting process. I don't expect you to be able to read it, but on the right-hand side there, is an image which is taken from the document. So I've just got that in there so you can see that there's, the porting engineer is taken through a kind of stepwise flow with decision points, making sure that you get the libraries ported in the right order, run the tests as you go along, make sure one library is working before you port the next, etc. Again, to try and make it easier for our users, at reInvent this year, we have just launched the AWS IoT device tester. This is a test automation tool. It sets up the cloud infrastructure and actually the infrastructure on your test host machine as well for you. It will also orchestrate running the tests for you. These are very, very small microcontrollers. We can't run all the tests at once, so it will run batches of tests at once, and then it will collect the test results and collate the test results for you. So that's a very brief overview of Amazon FreeRTOS. I'd now like to invite Tanmoy up. And Tanmoy is going to talk about BLE, which we launched in beta this week, and also go into more detail about over-the-air updates. Thanks.
Thank you, Richard. Hi, I'm Tanmoy Sen. I'm a product manager with the Amazon FreeRTOS team within the AWS Internet of Things organization. As Richard mentioned, I'm going to talk about the two important features that we worked on throughout this year. One is the over-the-air update feature, Amazon FreeRTOS over-the-air update, as well as the BLE support in Amazon FreeRTOS, Bluetooth Low Energy support. So as we talk to customers this entire year, we saw that there were millions of devices that were working on batteries, small coin cell batteries. You can imagine different devices such as fitness trackers, headsets, and smaller sensor devices running on coin cell batteries, and they need to be long-lived. They need to work on these batteries for a very long time. And they typically run low-power applications on top as imaginable, and they connect using Bluetooth Low Energy or BLE as a connectivity protocol to a mobile phone or a hub. So these devices typically run BLE and they connect to AWS IoT through the mobile hub. But today, however, we saw that when speaking to customers, developers faced enormous problems with that. Developers who wanted to add Bluetooth Low Energy or BLE connectivity to the Amazon FreeRTOS libraries had to go through an expensive process, time-consuming process, because especially if they're experimenting on 2 or 3 microcontrollers in their design cycle, they have to first choose what the microcontroller is, which one they want to use in their application. Then they choose what the BLE stack would be, a compatible BLE stack. And after that, they have to port and code Amazon FreeRTOS libraries on top. And finally, when the porting is done, they have to test it with the compatible Android and iOS SDK and the devices that they want to use. Now imagine, after this entire thing has been done, if you want to experiment on a separate microcontroller, they have to go through the entire process again. To mitigate these problems and for these applications especially, we launched the BLE support in Amazon FreeRTOS as beta. So this was announced on Monday, and you can go to our website to see the more details about it. What this support is, BLE support in Amazon FreeRTOS is basically enabling developers to use the standard generic access profile or GAP and the generic attributes profile GAT to create BLE applications that are portable across different microcontrollers. So you can imagine experimenting with different microcontrollers, and these applications are portable. What we are doing here is providing standardized BLE APIs that run and expose these GAT and GAP profiles through these standardized BLE API. Now, what this enables you is that when you have 2 or 3 microcontrollers that you're working on for your design, and you worked on your business functionality, the end application that we talked about, you don't have to think about changing your end application. It's going to be the same. You swap out microcontrollers and you get the same end application working for your design. In this release, we have also custom profiles for MQTT over BLE, for device to AWS IoT core connectivity, as well as Wi-Fi provisioning over BLE, which is for sending Wi-Fi credentials, such as SSID and password, onto the devices, Wi-Fi devices, over the BLE connectivity protocol. For those who are not aware, the BLE specifications define the GAT and GAP as 2 distinct attributes. GAP describes how BLE devices broadcast availability and communicate with each other, these devices. And when the connection has been done, GAT describes how data is transferred once the connection is established. And MQTT, as we all know, is a lightweight pub/sub protocol, publish and subscribe protocol for AWS IoT and connectivity. The standardized BLE API, as you can see on the diagram on the right and highlighted in pink, is basically an abstraction layer that we define for MCU vendor libraries such as the BLE stack, as well as internal Amazon FreeRTOS libraries. So you abstract away the entire the vendor supplied libraries as well as internal Amazon FreeRTOS libraries on top, and it will expose convenient APIs that you can work on for the end application and the user application that you are defining. You can also, the BLE API today that we have defined supports the GAP and GAT profiles, but it also supports creation of other custom profiles that we want to create with that. For example, if you want to send custom configuration data to your BLE devices, you can use that custom profiles too. For secure pairing, we have used BLE secure connections, which is an enhanced security protocol or methodology that was introduced from Bluetooth 4 version 4.2 onwards. And it basically what it does is it authenticates a peer device and creates an encrypted channel so that whenever you are pairing with, sending your data across the channel, the paired channel, it is encrypted and it's secure. And if you want to qualify your BLE microcontrollers on Amazon FreeRTOS, you can do so by using our user guide, Amazon FreeRTOS user guide, and as well as some of the tests that are in GitHub. So you can use the C.C tests to port and test your port, BLE port, as well as use the porting guide that Richard just mentioned in the flowchart to go through each of these sequences very clearly and finally see that the test and the port has been done properly. The custom profile for MQTT over BLE enables developers to connect BLE devices to AWS IoT Core via a mobile device as a proxy. And as you can see on the diagram on the right, these are the devices on the left, BLE devices, the mobile phone, and the IoT core, AWS IoT Core. So MQTT over BLE enables you to connect the BLE devices to AWS IoT Core via the proxy. It comprises of a new MQTT agent that we have written. It's in beta currently, but it supports both BLE and TCP/IP, so that the same MQTT library can be used for BLE as well as Wi-Fi connections onto AWS IoT. The iOS and Android SDKs that we have released with the beta release, provides the proxy libraries that you need to connect to AWS IoT. And there are simple demo applications that you can use to get started very quickly. The mobile device that you see in the middle uses the Amazon Cognito service to authenticate with AWS IoT. And if you're not aware, Amazon Cognito service is useful for sign up, sign in, and access control, provides access control to all mobile and web applications. So that the security between the mobile device as well as the AWS IoT is taken care of by Amazon Cognito. You might wonder at this point, what are the benefits of MQTT over BLE? Why do we need that? So it's basically MQTT over BLE. It not only provides the connectivity from your device to AWS IoT Core, you can connect your device to that. It's not only that, but you can use other services from AWS itself, which will be very valuable for your device when it's connecting to the cloud. For example, you can use AWS IoT Device Shadows or AWS IoT Device Defender. And in the future, you can use the existing infrastructure that we have for over-the-air updates for Wi-Fi for BLE too. So BLE connectivity and the transport layer can be used for over-the-air update in the future too. And AWS IoT Device Shadows, if you're not aware of what this service does, is basically helps you store and retrieve the current state information for your device, which is really useful for low power applications and low power designs when you're trying to store the state locally so that you don't have to reach out to the cloud always to see what the state is. And AWS IoT Device Defender is basically you can audit and monitor device configuration. So you can imagine a fleet of devices now in the field, and you have to detect anomalies. What's happening? What are the security vulnerabilities? And which of these out of the 10,000 or a million devices is actually vulnerable to security? And so you can easily detect that, and this AWS IoT Device Defender service lets you notify that these are the vulnerable devices out there in the field. The custom profile for Wi-Fi provisioning over BLE lets you provision, as we talked before, lets you provision the SSID and password to your BLE device and over the BLE connectivity protocol. So this also enables, you can imagine a field technician coming at home and installing home appliances or other IoT devices at home. They can easily run and pull up an app, BLE app, and put the SSID and password in, and provisions that to the home appliance, so you can easily get started. And the access point details are stored on the device. So when you next boot up your home appliance at home or the IoT device, it directly connects to your Wi-Fi access point. Users can also save multiple Wi-Fi configurations in case you're building or you have several access points at home. So you can save multiple. You can reprioritize one of them, because I mean, if you are on the first floor, you want to connect to a specific access point, you can reprioritize them. You can add and delete Wi-Fi configurations that are provisioned onto the device. For security, between the mobile device and the BLE device, we have also used the same standard that was introduced in Bluetooth version 4.2, which is BLE secure connections. So you can use the same protocol so what this enables us is that whenever we are sending the SSID and password to the device, we are sure that it's going through an encrypted channel, it's coming from a trusted entity. Again, there are demo examples, not only in the iOS and Android SDKs that we have released, but also in the Amazon FreeRTOS source code. You can download these simple demo examples you have and to quickly get started with the custom profile Wi-Fi provisioning over BLE. You might have noticed that this is really important for devices and boards and designs that have both Wi-Fi and BLE capabilities in it, because you have to provision using BLE, and then it uses Wi-Fi to connect to the cloud and the access point. So there are some chipsets and boards that are, for example, Espressif's SoC ESP32 that has both Wi-Fi and BLE capabilities in a single SoC that is really popular with developers and enable these applications in a very significant way. We have been working with Espressif to name ESP32. We have been working with Espressif for quite some time now, and embedded developers have really appreciated and seen that there are so many benefits from Amazon FreeRTOS and ESP32 SoC working together. So with that, I would like to welcome Amey Inamdar, who is the Director of Technical Marketing on Espressif Systems, to explain how Amazon FreeRTOS and ESP32 together solve so many problems that embedded developers and applications face.
Thanks, Tanmay. Hi everyone, my name is Amey Inamdar. As Tanmay said, I work for Espressif Systems in the technical marketing side. And so essentially, Espressif Systems is a semiconductor company which has a strong focus on Wi-Fi and Bluetooth connected microcontroller and solutions around those. So ESP32 is our current flagship product, which is very popular in the hobbyists as well as in the OEMs equally, to provide the connectivity to connect the physical devices to the internet. Right? And so ESP32 is a very tiny, like 5 mm by 5 mm size microcontroller, which has a microcontroller plus Wi-Fi plus Bluetooth and Bluetooth low energy interfaces in the same chip. And we have been Amazon FreeRTOS qualified. So ESP32 has been Amazon FreeRTOS qualified platform since this year's February. And so basically, if you see the use cases where the ESP32 is used, and they range from a very simple light bulb to very high-end big appliances, and from like very simple connected toys to industrial sensors. So we have a large gamut of customer base who have been using our solutions in various different applications. And that basically gives us an ability to understand some of the considerations as well as pain points while building as well as maintaining these connected devices in the field. And today I am going to talk about 3 such considerations where we see that the ESP32 port of Amazon FreeRTOS adds a good value to the customers, and I would like to explain a little bit more about those 3 considerations. So, the first and foremost consideration is of course security, and these days it is not lost upon OEMs, or most of the OEMs, even small companies, they realize the importance of security when it comes to the connected devices. And also they understand that security is not a single dimensional thing. It has multiple different dimensions, like you have to have a secure cloud communication where you make sure that your device and the cloud endpoint can mutually authenticate with each other, and the data in transit is actually encrypted using sufficiently strong security standards. Or when it comes to securing the storage, the physical storage on the microcontroller, you have to make sure that the data is secure, because it may be storing the Wi-Fi credentials of your home network or the device certificates, which can impersonate the device if fallen in bad hands. So, you have to really secure that as well, and OTA also has to be secure, so that you can you can make sure that the device is fetching the upgrade image from the trustworthy source and not from somewhere else. Over all of these, you have to make sure that the application which is working on the microcontroller is trusted, otherwise the rest of the security just falls apart. Now, the semiconductor companies and the platforms provide in both the hardware as well as in the software all the different security features. However, onus of implementing the right security policies still resides with the OEMs and their developers. If you see, typically small and medium OEMs seldom have resident security expert in their teams to build a secure connected product. So, it many times becomes overwhelming to make sure that the good security policies are implemented, designed and implemented in the device. And that is where Amazon FreeRTOS and ESP32 port of it provides a big value to the customers, because the good security practices are followed in the design, and all these considerations like using the TLS for the communication or certificate based mutual authentication, or making sure that the application is trusted and the hardware boots only the trusted application. All of such security policies are well implemented in the system. Also, security is not just one time thing, right. So, as you know, as the platform gets fixed with various different fixes, it is important for the OEMs to roll out those upgrades to their devices in field, and making sure that the platform which is continuously being maintained also helps them significantly. And this actually brings me to the second point that I would like to talk about, and that is about the OTA upgrades. Now, if you see, traditionally in the absence of a standardized OTA service, the customers used to develop like a very simple OTA scheme, like check if the new upgrade is available, fetch the upgrade image and program it onto the device, so that the device boots into the new image. So, many a times customers used to take a very simplistic approach, like have a simple web server which can give you an API to check whether the new upgrade is available, then use some file server to serve the OTA upgrade, and then use that scheme to implement your OTA upgrade. However, this used to result in not so good kind of experience from the customer when it came to the management of the OTA, because the customers have different needs, like I want to roll out my upgrade selectively to a certain set of users to first test that the upgrade is working fine, and then make sure that it is rolled out to everybody else, or I get to see how many devices in the field I have actually upgraded to the new version of the software. So, all of that is used to be rarely available for the customers. Also, rollback is important. In case my new firmware does not behave well, it should automatically roll back to the older version of the firmware. It is an important feature. And whatever custom schemes customers used to build using that, there is always a chance that if they make a mistake in any of these, there is always a possibility of breaking the entire device in the field, which is which may be a big problem. But having an OTA service in the cloud and having the same agent on the device, the corresponding agent on the device, simplifies the OTA to a large extent for the customers, and it provides all the required features that customers desire in deploying and maintaining their connected products in the field. So overall, Amazon FreeRTOS provides a very good hassle-free experience for the customers when it comes to the device OTA management. And the next, the third topic I would like to talk about is the openness. So both ESP IDF, on which the Amazon FreeRTOS port is based, and as well as Amazon FreeRTOS, both of them are open and free platforms. And we have seen that many a times the IoT projects start bottom up in the organization. A small team starts working on the project and it becomes a product eventually. And in that phase, it is very important for the customers to quickly evaluate all the capabilities of the platform, and that is where the openness and the freeness of the Amazon FreeRTOS and ESP32 port comes very handy. Also, it provides a lot of flexibility in the development and maintenance. So, for example, as the entire source code and the development process is visible on the GitHub, so you can easily pick the patches that are relevant to your development even when your product is deployed in the field. Also, you can selectively deploy the required features to given set of devices in the field, because it is completely controllable by you because of the openness. And it also benefits from the community, because there are a lot of contributors like who are like contributing like peripheral drivers for a certain type of peripheral that you are using in your design, and there is a high chance that you may already have the somebody who has already written that driver for you in the field. Or having it open also means that there are a lot more eyes looking at the code, which contributes significantly to the security of the overall system. So all of the benefits are like directly or indirectly beneficial for the customers because of the openness and freeness of the system. So those are the three important points I thought I should talk to you from our experience. And with this, I'll give it back to Tanmoy. Thank you.
Thank you, Amey. So we have used the ESP32 chipset for a demo that we prepared. I mean, it's a video, a short video that will give you two important features that customers really asked for this entire year that we spoke to all customers. One is they have their BLE device. How do we connect it to AWS IoT Core? How do we use the cloud and the benefits in the BLE device itself? The second thing that we saw is that there are so many customers having appliances and IoT devices with both Wi-Fi and BLE capabilities. Now, how do field technicians provision the Wi-Fi credentials using the BLE communication channel? And that is what customers said, that it's really simple to do that using BLE rather than choose any other method. So let's quickly go through a short demo to see how this is done. The two use cases, these work out. So on this screen, you see three subscreens. One is the MQTT client, which shows the MQTT messages sent to AWS IoT. The device console, which shows the output of the BLE device. And the third is the mobile app, which lets you interact with the BLE device. First, we start with the pairing and bonding process between the BLE device and the mobile phone. The BLE device starts off by advertising its presence. The mobile device captures it, detects it, here as ESP32, which is we used for the demo. And as soon as the pairing process is complete, the keys are exchanged, we see that the pairing and the bonding process is now complete. Next, we go to MQTT over BLE. As soon as we enable MQTT over BLE, we see that there is a two-way communication between the BLE device, which is the bottom black screen, and the MQTT client, which is on top, as you can see highlighted. So there's a two-way communication, acknowledgements and hello world going forward. Next, we look at Wi-Fi provisioning over BLE. So when the BLE device starts on and we scan for networks, BLE device scans for networks. Here we selected guest as the network, but this application or the custom profile lets you choose any Wi-Fi scanned access point. Here you can see on the screen. You can send the SSID and password over to the device, and once that's done, you can easily provision the device. You can see that the saved networks here, you can reprioritize and even delete one of the configurations if you need to. But as soon as the credentials are passed on to the BLE device, your device is actually ready to be connected to the local access point. So that was a very quick demo showing the two use cases we have done with ESP32 chipset. But these are some of the use cases, and you can create custom profiles on the BLE abstraction and the standardized API that we have created on BLE. Wi-Fi provisioning over BLE has been one of the most important features, apart from so many others that have helped Pentair in their next generation of smart water products. So Pentair is a leading water treatment company that we all know based in the US, and that delivers a comprehensive range of smart, sustainable water solutions to homes, businesses, and industries. I'll let Rama Bodampati talk more about it and how Amazon FreeRTOS and the ESP32 chipset solve their problems, their requirements, and met their requirements. So I'm excited to welcome Rama Bodampati, who is the Senior Director of Smart Products and IoT at Pentair. Rama.
Thank you, Tanmay. Hello, everyone. Glad to be here. So as Tanmay mentioned, my name is Rama Bodampati. I lead our enterprise-wide global innovation center on smart products and IoT at Pentair. And I'll take a couple of minutes to quickly talk about Pentair before I get into our partnership with the Amazon FreeRTOS team, as well as with Espressif. So at Pentair, our brand promise is to provide smart, sustainable water solutions for our customers for life. And we take this brand promise very seriously in terms of providing smart solutions, but also sustainability, right? So in terms of the range of solutions that we provide, I'll talk very quickly about this and then also give you an idea about some examples about the solutions as well as where IoT plays a critical role. I'll start out with residential. We are a big player in the residential space when it comes to water treatment. So think of your pool products, for example. We make a lot of pool equipment like pool filters, pool pumps, pool heaters. We are the #1 player in the residential pool industry. And we recently launched a product earlier this year called IntelliConnect, which just won the best new product at the pool show a couple of weeks back in Vegas. And that's a connected pool product that essentially gives the homeowner the ability to control their pool remotely and set schedules and program their equipment remotely. And it's a complete IoT solution. So that's an example of a residential IoT solution which provides significant value to our customers. On the commercial side, I don't know how many of you were part of the IoT leadership session earlier today, but Dirk actually talked about a couple of IoT solutions that Pentair currently offers. One of them is in the aquaculture area, again around fish farming, where IoT solution really helps provide a sustainable solution for smart aquaculture applications. Industrial, tomorrow we have a session at 4 p.m. talking about the anatomy of a successful IoT story featuring Pentair. And in that we'll provide more details. It's around beer manufacturing and where IoT solutions in an industrial setting provide significant value to our customers. And a couple of other market verticals where we offer smart, sustainable solutions, muni and infrastructure applications, as well as agriculture, especially around precision ag type of applications. So across all of these, as you can tell, IoT-based solutions definitely provide significant value to customers. And here's a brief snapshot of the type of impact that we can make. I know at AWS reInvent, as you must have seen in the swag material that you got, there's a lot of emphasis around water and sustainable solutions towards water. This is our impact of small impact that Pentair has been making in this space in terms of how much water we can save and how much of benefit we offer globally. So now jumping into the topic around Amazon FreeRTOS and our partnership with the AWS team as well as with the Espressif team. So as the speakers before me covered, the problem statement is pretty typical, based on our conversations, even at reInvent, with companies similar to ours. This problem statement keeps resonating with a lot of similar companies such as Pentair, right? So one, we definitely need to provide these IoT solutions, but we're talking about these really low cost-effective battery-operated type of sensor devices, edge devices. They have very limited processing and memory capability, right? So how do we leverage a small team that we have, the limited resources that we have, but really figure out how to get to the market fast, right? And provide the IoT solutions, some of the IoT solutions that I mentioned in the previous slide. And so this is where the AWS team as well as the Espressif team really came in and provided strong support, and that led to a strong partnership with both of them, right? So the fact that we had FreeRTOS kernel experience in our team obviously was helpful, but I wouldn't say that was the main reason why we took the plunge here, right? The main reason why we took the plunge was the features, the benefits, which I'll get to in the next couple of slides, is the reason why we really decided that we would go all in with Amazon FreeRTOS moving forward. The out-of-the-box support like OTA, I know we had a demo just a few minutes back around BLE, so we have been using this BLE SDK that just got announced earlier this week on Monday, right? We've been working on it for the last couple of months with support from the AWS team, and we've been using it for Wi-Fi provisioning. So we have these sensors that are both using Wi-Fi and BLE, and our technicians, our installers would use BLE to provide the Wi-Fi credentials to the device before it would connect to the internet, right? So that's a feature that we definitely absolutely needed, and both Espressif and Amazon FreeRTOS team helped us get there. OTA, again, we wanted to make sure that we didn't have to reinvent the wheel here. We just relied on the support that we were getting from them and almost out-of-the-box feature that we had. Security is important. I'll get to that in a minute. OTA over Wi-Fi. So unlike the demo where we could do OTA over Bluetooth, we haven't really explored that yet. But right now we are doing OTA over Wi-Fi, and this is critical for us as we are getting into field trial stage right now for some of the new and upcoming products, because we did not want to wait for all the features to be developed before we start field trials. Especially in our applications, field trials tend to take a very long time. For industrial applications, as you can expect, our customers demand that we do a pilot for 6 to 9 months at a minimum before we can scale it up, which means that we need to get these field prototypes out as quickly as possible. And the only way we could do that and successfully complete the pilot is using OTA. So that's where OTA becomes a critical feature for us. BLE, I already mentioned that. The one thing that I didn't get into is that on-site device maintenance and service. This is critical in terms of the service personnel, the service technicians that we have. Again, visiting these field trial units, making sure that they're able to configure them and make certain adjustments is important. And our customers do not want to provide these Wi-Fi credentials to our service technicians, which means the only way they can communicate to these devices is using BLE. So that's where BLE comes in quite handy. I think Tanmay already mentioned the SD case. So far we've been using the iOS version. We are looking forward to also starting work on the Android version. But the iOS version is what we've been using so far. Security, I mentioned that I'll get to security in a few minutes earlier. This is, I think, one of the main reasons why we really decided to go ahead with Amazon FreeRTOS. This is not part of our core competency by any means, right? And we didn't really want to understand all the gory details, not just in terms of what's the state of the art when it comes to security today, but also in terms of how to keep up with the ever-changing rapid pace of all the security issues that we might encounter in the future, and then how to deal with resolving them, right? And so the partnership really helps from that point of view. And then, sorry, I clicked too fast, I think. And then device management. Especially when it comes to these field trials, how do we do these fleet management or group management? How do we do OTA for certain groups of devices as we are trying to test out new features? And then once we get into launch, based on the customer profiles that we have, the different types of groups and different types of group management really become critical for some of our applications. So that's where, again, the device management plays a critical role from our point of view. And I think with that, I will hand it over to Tanmay. Thank you.
Thank you, Rama. So with BLE, there are easy three steps to get started with BLE support in Amazon FreeRTOS. As we can see on the screen, the first step is to choose the supported hardware from the AWS Partner Device Catalog. AWS Partner Device Catalog is a new service and a fully managed device catalog that we launched recently. It was yesterday that we launched. And you can go to the AWS IoT website to see a separate tab called AWS Partner Device Catalog, and you can click on it. You can select the Amazon FreeRTOS qualified devices and other devices that are AWS supported, and you can choose one of these devices and get started with it. For BLE support in Amazon FreeRTOS, what we have initially launched with as beta are 4 boards. As you can see on the screen, Espressive, we have the ESP32 Dev Kit C, as well as the ESP Rover Kit. From Nordic, we have the nRF52840 device, as well as from ST, we have the STM32L475 Discovery Kit IoT node. That's a really popular board, as well as it's combined with a separate BLE module called the SPBTLE1S, which is based on the Blue NRG1, if you are familiar with that BLE module. So this supports BLE 4.2 right now, but coming soon in 2019, we are going to support the STM32WB dual core SoC, which is a system on chip based on BLE version 5.0. The second step in getting started is to download the source code. You can download the source code from our GitHub repository, Amazon FreeRTOS GitHub repository. Within that repository, you'll find currently we have the beta branch. You can download the source code from that. For the companion Android and iOS SDKs that you need, you can go to the GitHub repositories, the corresponding GitHub repositories in GitHub, and you can download the source code for the Android and iOS libraries. Within these, you can also find documentation, easy step-by-step guide that you can use to actually get started. The third step within the getting started is to refer to our user guide. So all the boards that we have qualified, the boards that are Amazon FreeRTOS qualified, they will have a separate section within the Amazon FreeRTOS user guide. So you can if you choose one of the boards, for example, if you choose the ESP32 Dev Kit C right now, there's a separate getting started section. You can go step by step and connect to AWS IoT. Following the steps, it will give you a clear indication as to how to get started. Rama talked a lot about technicians and field technicians and finding it difficult. So talking about technicians again. Over the last few years, we talked to so many customers. We saw that if you want to update one thing, one IoT device at home, for example, or any office or any industry that you have, if you want to update one device with security fixes and updates, you call technicians, you call field technicians. They can come home, come to your office, they can fix release the updates, wire it up, and do that very easily. Now, when you think about 1 million smaller sensor devices, you cannot call technicians at that point. If you want to do updates every 3 months, every quarter, it's really impractical to have technicians and go and do the updates. At this point, you think about connecting it to the cloud and doing the over-the-air updates. So this is a solution that you can think of. This is one of the alternatives that you can think of. But we are talking about small sensor IoT devices that are running on microcontrollers. And microcontrollers, as we all know, these are constrained devices. These are small devices having small compute power as well as small memory. We are talking about kilobytes of RAM and kilobytes of some simple kilobytes and megabytes of flash. So we have to save each and every kilobyte in our designs in doing the over-the-air updates. That's not it. When we are talking about millions of devices, updating millions of devices, we have to talk about security too. You have to think that the firmware that is being pushed down to the device is actually originating from a source that you trust. It's going through a channel that is encrypted so that you are sure that it hasn't been tampered with during transit. So all of these constraints really put a lot of effort on, let's say, someone who is trying to design the over-the-air update feature. We understood all these requirements. And for these applications and to meet these requirements, we launched Amazon FreeRTOS over-the-air update earlier this year. Over-the-air updates, what you can do is you can log into our AWS IoT device management console, and you can use the AWS IoT device management console to remotely update devices or a group of devices. You can think if you have got around 10,000 sensor devices at one floor in a tall high-rise building, you can think of updating floors 2 and floors 7 by choosing the separate groups in the device management console and updating them with the firmware that you need. You also get the ability to code sign the firmware. When you send it across for the update, you get the ability to code sign the firmware images while scheduling the updates. And the devices have the capability to validate the signature once the firmware updates go to the devices. So there is a separate agent that validates the signature of the firmware that's been pushed onto the device, and you can see that it's coming from a trusted source and it hasn't been tampered with at that point. Updates are streamed to the devices over the MQTT channel. And this is really important to note at this point because we are using the same TLS connection that we established in connecting the device to the cloud. And TLS is the largest consumer of the kilobyte that we have, the constrained kilobyte that we have in the device. So we can see that we are using the same connection, TLS connection, to send data over MQTT as MQTT messages down to the device, and it gets updated in the device itself. So this is really beneficial and pertinent to microcontroller devices that we have all around today. After the new images are downloaded, we have simple APIs to control the installation and the reboot logic with the new firmware that was pushed to the device. We talked to Vestel earlier this year, and Vestel is a large home appliance OEM based in Turkey. And they were working on a smart auto-dose washing machine. And the use case was as follows. They wanted the washing machine to connect to AWS IoT Core over the Wi-Fi connectivity protocol. And they wanted to run it just for command and control. But they also wanted to have security updates and new programs pushed to the device in case any security vulnerabilities arose in the future. So it could be once in a quarter, it could be once in 6 months, but the frequency depended on when the security vulnerabilities arose. So let's look at how Amazon FreeRTOS met Vestel's need and their requirements, and how it solved their problems directly from Burak Savak, who is the VP of IoT at Vestel.
We as Vestel is one of the biggest manufacturers in Europe. We are manufacturing more than 10 million white goods per year. And while making our products connected to the internet and becoming a major player in IoT, we were looking for a scalable and secure solution. Because of the nature of the white goods products, we were looking for a small print RTOS that can satisfy our needs, like security, OTA, and remote management. In the light of that, we contacted with the Amazon team. They suggested us to use FreeRTOS. When we examined, the results came up quite promising. And alongside with the Amazon team, we made a small POC. After the POC and the good results, we also enabled in our products, and we will be deploying FreeRTOS in 2019.
Now let's change gears a bit and let's dive into some of the technical details as to how OTA is performed on the FreeRTOS devices. OTA over MQTT has two distinct owners, as you can see on the screen. On the left-hand side, you can see the operator or the author of the updates. The user is actually the one or the operator who schedules the OTA update job. And on the right, you can see the device which takes control of after the update job has been scheduled and ensures a smooth update process happens after the scheduling has been done. At first, the operator, authors the firmware update. They can use the pre-existing services such as to create OTA policies and service roles. They can use services such as key management, AWS key management service, or AWS identity and access management, or AWS certificate manager. These are the services that we used for the first process of creating the update job. Users can also use new services such as code signing certificates to create the first upload process. Then the author uploads the firmware to Amazon S3, the simple storage service, and the image is stored in S3. Then the user schedules the update job using the AWS IoT device management console, where he or she can sign the firmware and select the Amazon S3 bucket. For advanced users, OTA can also be scheduled using command line interface or CLI. But the UI gives you a simple interface in which you can select different selections, and it helps you get started very quickly. Once the OTA update job has been scheduled using CLI or the terminal UI, the devices are notified that an update is coming. At this point, the device, especially the OTA agent within the device, takes control. The device downloads the new images in chunks from AWS IoT Core and writes those chunks in a separate partition within the memory map. The primary image is on the left that you can see is still the one that is currently executing. The OTA agent now stitches the chunks together in sequence and verifies the signature at this point. And if the verification is successful, it sends a notification that the new image is ready to be used. At this point, the bootloader within the device takes control. It verifies that the new image is right and initiates a self-test. It's the last test that the scheduler performs to see if everything has been working properly. If all checks pass, the older image is deleted and the device boots from the new image, which is now the primary image. The old image is deleted as one of the security practices to prevent the device to roll back to an unsecure image. But this can be done in hardware and other methods too. Finally, the device sends the status to AWS IoT Core that the OT update job has been successfully completed. This was the entire mechanism, but there are, again, you can imagine 3 steps to getting started on OTA2. You can choose the supported hardware platform from AWS Partner Device Catalog that we just saw in the previous screen. If you don't have the hardware, or if you just want to experiment with the software, you can also use the Windows Simulator version, which is a separate port that doesn't use hardware, to get started. Next, you download the source code. You can download the source code in 2 different ways. One is using the Amazon FreeRTOS console, which gives you the flexibility to choose hardware, choose the IDE that you need for your project, choose the compiler, And you can download the libraries that you need for your project. If you want to use just the Wi-Fi library and Wi-Fi application, you can just download Wi-Fi, and it automatically downloads all the dependent libraries for Wi-Fi to get started. You can also download the entire source code from Amazon FreeRTOS master repository, GitHub repository. The third step is to refer to a user guide, the Amazon FreeRTOS user guide, which is a step-by-step process to get started, and you can choose the particular hardware section within that to get started on your board that you see, right? With that, you'll find more information on our website, aws.amazon.com/freertos. But you feel free to reach out to us using the AWS forums or the GitHub issues. In a short moment, we'll be opening up the floor for questions, but we would like to thank all of you for your time and attention and patience. Thank you.
Does anybody have any questions? Let's see.
So will you be adding libraries of sensor drivers or LoRa or anything like that, or you have to port that yourself?
So the question then is, are we going to add in sensor libraries or LoRa or something like that? Because everything is open source at the moment, you are completely free to integrate anything that you want to, of course. As far as the plan moving forward, everything is very much customer driven. So if the feedback we get from people like yourselves is that LoRa is something which is going to be like the next most helpful thing for our users, then that would get onto the roadmap. There's obviously a lot of different connectivity protocols, and it's a matter of prioritization.
What if your program takes up more than half of the flash? Do you still do an OTA? Is there some magic that you can do? Because you can't have the old program and the new program.
Yeah, so the question then is, well, what if your program takes up more than half of the flash? Again, I don't want to sound like I'm repeating myself here, but because this is open source, you can do OTA however you like. The scheme that we have come up with, as Tanmoy said, is specific to enable people to perform an OTA with the minimum amount of compute and the minimum amount of RAM possible, in that you have the same TLS connection and you have MQTT already. But that's not to say that's the only way you can do it. We also don't know what hardware people are going to be running on. So everything, all the interfaces that we have are abstracted to allow you to run things on various different hardware platforms. So nothing is actually kind of fixed and set. So we do have some examples already where we have external flash over SPI memory, and we download into there temporarily and that kind of thing. I think if you were wanting to really screw down to the smallest microcontroller possible and do OTA as well, then you would need probably a more sophisticated bootloader. The reason I say that is because if you have overwritten all or part of the primary application, in order to recover in an error, you would need some functionality in the bootloader to enable you to then start downloading again or whatever.
Thank you. Is there native functionality to integrate some of the security chips, like the microchip 508s, the ECC 508s, or any of that stuff?
Yeah, so the interface to, well, actually, I'm not sure if I can't recall if I mentioned before, but everything we implement, we try and use open standards for. So as far as the crypto stuff goes, we use the PKCS11 API, which is, I believe, very widely used. I should say that we use a subset of it. It's a big standard, right? And we've got very small microcontrollers. So we use a subset of it. And you can implement a port layer for that to run on, to interface to any crypto or key storage that is available on the MCU. One option of which is not just the microchip part, but several manufacturers have these parts. Any other questions?
In one of the examples, mentioned not wanting to expose the Wi-Fi keys to the technician, but the technician has Bluetooth access to the device. Couldn't they get them that way? Can they download the image, or is there some sort of security protecting them from getting anything on the device over Bluetooth?
So the question then is, if we don't want the technician to get access to the keys, and I have to say at this point that I don't know if you can answer that. Someone else can answer that. Yeah.
Yeah. So I think it is possible only if it is by design. So if the OEM intends the technician to have capability to do that, then they can do that. To answer the second half of your question is whether it is possible to protect it at the device level itself, so that technicians do not read unintended information directly from the flash. Then the devices like ESP32 have the features like flash encryption, which will encrypt the entire flash where the secure, the sensitive information is stored in the flash. So by just reading out the flash, it won't be possible for technicians to read out the critical sensitive information.
Anybody else? No?
Okay.
Well, once again, thanks for coming this evening.
Thank you.
And,